Yeah, my name's Kent Marten. I'm the product manager for Geospatial at Databricks, my first SDSC. Thanks for having me. In this talk today, it's a lightning talk, so I'm going to cover a number of topics rather quickly. But also a topic that has come up today is, what is the Lakehouse? So I'm going to talk about what is the Lakehouse and the Lakehouse platform that we have at Databricks, what we've done to advance H3 and how we work with H3. It's a really great lead-in. I didn't know all of the details of Paul's talk, so great to see him sort of espousing his use case. And I'll also highlight a number of geospatial solutions that we're building or have already built that people can pick up and run with. All right, let's do it. So when we talk about Lakehouse, it's good to look back a little bit and see where people have started, where technology companies have started, and how they've been successful. I think if you look down and to the left, you're kind of looking back in time a little bit, thinking about how traditionally data-driven companies have worked with data, right? They've tried to be successful cleaning data, building reports, exploring data. And I think a lot of, this is kind of a ubiquitous pattern amongst data-driven organizations. But I think there's definitely a desire to be more to the right on this graph, right? And the technology leaders of the day tend to be more successful on this right-hand side of the graph. And that's being more predictive, prescriptive, and automated, right? And you can see a sort of natural divide here. You have the kind of BI-driven use cases and the AI-driven use cases. So you have this separation. And where technology companies need both of these things, which is most organizations, it tends to lead to disparate systems that get built up to support those use cases, which we could say looks a little bit like this, right? On each side, again, sort of in the narrow lane of those platforms, you can be successful, but it does come with some baggage and some issues that arise if you want to be a really well-integrated and successful company, working with data and driving towards those predictive and prescriptive automated outcomes. So you get, ultimately AI can be really, powerful when it can bring in more data sets as needed. So there's an opportunity here, unfortunately, for data duplication when you have disparate platforms. Of course, with these sort of platform architectures in mind, you're going to run into different governance and security models, and ultimately they serve different sets of use cases. And you are required to build and use different technology to serve those use cases, and people need different skills to use those technologies, etc. But the Lakehouse says you don't need these two disparate systems. This is the heart of the Lakehouse, right? When it comes to data, whether it's structured or unstructured data, semi-structured data, it can stay in the storage layer of the Lakehouse. A unified model for governance and security, and the ability to support all use cases, SQL analytics, streaming, machine learning, etc. So that's the Lakehouse, and this is the Databricks Lakehouse platform, right? And it's built on sort of these three main tenets. Let's be simple, so we have this unified way of doing data warehouse type workloads and AI type workloads, built on open source with open standards in mind. It's a key part of the Lakehouse paradigm. And also multi-cloud, so you have a consistent experience across all of the major clouds. Okay, so we know what a Lakehouse is. Done. I'm not talking about that at the party tonight. So let's put a geospatial lens on it just for a second. I know there's a lot on this slide, but I'll kind of focus in on maybe two kind of key attributes, right? The Lakehouse, being a flexible place where data can land and live, is great for geospatial data because there's no other domain that has sort of more formats and ways in which the data can live. So you can bring in vector, raster, LiDAR, all of the sources of data can come in. That's great. This data could represent static kind of data that doesn't update frequently, like census data or demographic data, but can also be high volume, real-time, massive scale, IoT, sensor-driven data. So the Databricks Lakehouse platform can take any format of the data that's coming in, batch kind of streaming data, real-time streaming data. So very flexible in working with formats and sort of the velocity that the data is entering the lakehouse. And then, of course, just within the platform, like I alluded to, we look to build out solutions and get people started, regardless or covering all industries, because geospatial is everywhere. So once you have your data into the lakehouse, right, how can you be successful given the myriad of data formats and the types of questions you might be asking? With Databricks, we're a platform, and there's lots of ways the platform can be extended through libraries and through partners. So you may have seen some of these before if you're familiar with Spark or familiar with the platform. This is just a small sample of libraries and frameworks available I wanted to call out. But I also wanted to say with Carto, they're a key partner that we work with and have collaborated on closely, and I wanted to highlight a couple of the things that we've worked on in the last year. So first, the spatial extension for Databricks, a way to spatially enable your lakehouse. It's great because you can sign into Carto, connect to your Databricks environment, and issue those sort of familiar SQL spatial queries directly to the back end. There's also more coming and more in development. You've heard people talk about delta sharing. I think Paul mentioned it previously. We're looking at exposing Carto's spatial data catalog, data observatory type data sets through delta shares, again, sort of easing and reducing the amount of time you have to move data around, right? So highly advantageous. And then with H3, so I'm just going to keep referring to Paul's talk. It was comprehensive sort of introduction here. But with H3, we've built H3 into the platform, right? And we've done that in collaboration with the team from Carto so that Carto can also leverage those capabilities. So let's talk about that just for a minute, right? I mentioned advancing H3. Well, let's get into what we've built into the platform. And I know we've covered a lot of this indexing strategy today, so I'll get through this section a little bit quicker. So why did we do it? Javier explained it this morning in the keynote. He did a great job. The grid indexing system, there are many, but with H3, it's really built to scale, right? You're not working with any type of complex structure for storing geospatial data. You're turning it into a string or an integer and then working off of that. In the platform, we've built in 30 expressions. Some of those are similar to what you would see, or exactly what you would get out of using the H3 library itself. Others are new sort of optimizations that we've built. But the driving reason behind building H3 into the platform is around this sort of pattern and trend that we've seen with so many customers. And that is that they're using the indexing system and this pattern for doing spatial joins without having, there is a trade-off involved, but without requiring the spatial predicates, just doing an equality join based on index values. And it's a great way to combine data and work in the index space for doing spatial analytics. But H3 is, it's nothing new. We've talked about it. Everyone here knows what it is. And at Databricks, we knew that, but we wanted to spend our time really building out a world-class implementation of what H3 could be and really accelerate massive scale spatial analytics. So we do that by leveraging Databricks' Photon query engine, like a high-speed, high-power query engine. And our goal when we started to implement the H3 functions was really just to try to improve performance of each individual function by, say, 20 to 30%, which is significant, right? If we said right now you could get a 20% increase in your query in the time it would take to run that query, I think everyone would say, yeah, sweet, like I want that. So that's where we started from. And I'm happy, excited to share that we've got some really great results, and all of this is, again, available in Databricks today. So with sort of categories of H3 functionality, I know everyone probably doesn't have like a, dictionary, encyclopedia of all the H3 functions, but you have to trust me. So for import type functionality like long lat to H3 or polyfill to H3, we're seeing on average about a 40% increase in performance for executing those functions within a query, with some higher and some just a little bit below that. But if you get into the category of traversing the hierarchy that is H3, moving to parent or moving to child, again, the performance gains we're seeing are 6x, and in some cases much higher if you're forced to work with string data. You should really work with integers, but if you have to, the performance gains are significant. So we're really excited about sort of how we've managed to push H3 and its performance capabilities within the platform. So hopefully we'll see lots more examples of people using H3 and leveraging it. Okay. And of course, like I mentioned, we work closely with Carto on this stuff. Carto's the first third-party partner to leverage our built-in APIs. Awesome. Thank you, Carto, for doing that. And the H3 sort of performance-accelerated functionality will just make all of those sort of interactive, exploratory experiences in Carto, the high-speed visualization experiences, that much richer. So look forward to working more on this in the future, too, with the team. The last section I want to talk about are some of the Geospatial Lakehouse solutions that we've been working on. For folks that came to the workshop yesterday, we ran through all of these in detail and have these assets available to share. But I'll just cover sort of a quick coverage of each of these solutions. So the first one here is really just, again, looking at what customers do today. We have lots of customers who work with and process OSM data. So we built a solution, and the example here is taking all the building data from Italy and segregating the data into different tables by building type. Again, the focus here wasn't to necessarily answer an analytical question, although you could clearly start to look at things like urban sprawl or access to services. It was about an approach to data engineering, right? There's so much time spent on preparation of data and cleaning of data. It's really important to have a good head start and examples for following for data engineering. So there's a solution that helps you walk through and leverage Delta Live tables, a very reliable data pipeline system for processing OpenStreetMap data. But of course, the other really, really common spatial type of data that we see is file formats that we all know and love or hate. Shapefiles, GeoJSON, CSV data. So we also have solutions that work with these common formats and examples that do this, allow you to bring in those types of data into the Delta Lake and then convert that data into index space and do some of the operations we've been talking about over the course of the day. Site selection is a super popular topic and could be applied as a pattern in different ways. Our solution in this case is really to leverage some of the open source tooling like GraphHopper, some of the open data, whether it be from a state agency open data portal or OpenStreetMap type data, and then leveraging isochrones to look at real travel time, right? It's really not the best practice to use a straight as the crow flies distance for thinking about proximity to places when we're talking about movement of people. Often we're following some network, whether it's the bike path or the road network or whatnot. So we have this example that leverages isochrones, and within the template, you can arbitrarily add other parameters as well to make it further, adhere to your criteria for doing this kind of analysis. And then, the last example I just want to bring up, which is sort of in the works, is an example that looks at proximity to between two sort of events or locations, and does like a classification type, clustering method to actually understand proximity based on the criteria that you've included. This is based on a model which is essentially like a spatial k-nearest neighbor type model. And the thing I want to share about this, again, it comes back to performance in a lot of cases. In the example that was built out, we weren't just talking about a single building and a small set of events. This data set, which looked at New York, was looking at 100,000 buildings and 1.6 million taxi location rideshare type pickups. And we were able to execute this model in its iterative approach that leverages H3 indices and compute that in 5 minutes approximately. So this is a extremely performant method for doing this kind of proximity analysis. If you want to follow up on that one, again, after the talk, please come out to the Databricks booth and come chat with us. But I can see my timer is counting down in less than 10 seconds. So the last thing I want to say is we have lots of other examples. Maybe I should have just picked one and gone deep on them, but I chose to kind of quickly try to cover a lot of different topics to give people a sense of the art of the possible and let you know that we're thinking about performance and best practices for a wide range of use cases. Okay, that's all the time I got. Thank you.